Okay, in today's X-Minute Math video, we are going to be looking at a quick, easy, foolproof method for simplifying square roots. And we'll also look quickly a little bit at why it actually works like it does. So to begin with, I want to ask you what will turn out to be a trick question, just full disclosure. So the question I'm going to ask you is, which of these quantities is bigger? Okay, you might have an intuition here, but let's see. So the square root of 27 or 3 times the square root of 3. Okay. Well, square root of 3 sounds pretty small, but I am multiplying it up by 3 times itself. But on the other hand, 27 is pretty big. If I take the square root, what's going to happen? Okay, if I have my calculator, I can of course just plug these in, see what I get. But a sort of roundabout way of figuring out which is larger is just to square both quantities. Okay, if I square, okay, the smaller number will square to a smaller number, and the larger number will square to a larger number. The advantage being I won't have any square roots anymore. Okay, so let's see. So when I take the square root of 27 and I square it, by definition, okay, I'm going to get 27. The square root of 27 is the thing that when I square it, it gives me 27. On the other hand, 3 root 3, if I square that, well, let's just write it out in full. I get 3 root 3 times 3 root 3. Now I can use some properties of multiplication here to rearrange this product. I can gather the factors that are 3, and I can gather the factors that are root 3, and I can rewrite this as 3 times 3, 3 squared, and I can take root 3 and write that as root 3 squared. Right? I'm just using the commutative property of multiplication of the real numbers. So when I do this, well, 3 squared is 9, and root 3 squared is 3. So that gives me 27 too. Okay, so that's when I square both quantities, I get 27. So actually, the trick question was neither is bigger. These quantities are equal to each other. So what we just saw is a really straightforward example of what we call the product property for square roots. Okay, and it simply says that if we have the square root of a product, a times b, where a and b are just any real numbers, okay, if the square roots are well defined, I can pull this product apart as the product of the square roots, square root a times square root b. So I'm telling you these two quantities are equal, and we can see it just in the same way as before, right? If I square both quantities and I get the same answer, that tells me that the left-hand side and the right-hand side must be equal to begin with. Okay, and it's going to look very similar to what we just did. So if I take the square root of a times b and square it, again, by definition, I'll just get ab back. For this other quantity, okay, I will take root a, root b, and square it. Let's write this as root a, root b, times root a, root b. I can again use the commutative property of multiplication to rearrange the factors in this product to get root a squared times root b squared. And now if I just rewrite this, I will get a times b. So indeed, this product property works out pretty nicely. So let's see it in action. Okay, this is actually going to help us simplify some square roots. So let's take a simple example to begin with. So let's say I want to try simplifying the square root of 50. Now here I just mean write it in a simpler form. Okay, now simpler is often in the eye of the beholder, so let me show you what I actually mean here. Okay. Now the key here is I can write 50 as 2 times 25. Why is that an important, interesting way to write 50? Well, 25 is a perfect square, right? It's 5 squared. So when I pull this square root product apart using the product property, something really nice happens. So let's pull this apart as root 2 times square root 25. Now, root 2 isn't a particularly simple number, but square root 25 certainly is. It's just 5. So root 2 times 5. So writing this a bit more conventionally, we'd write that as 5 root 2. So when I'm talking about simplifying a square root, what I mean is I'm looking for a whole number that I'm able to pull out the front, and I'm leaving behind under the square root some other number that doesn't let me pull anything else out the front. Let's see this with another example. So let's up the ante a little bit. Maybe last time we got lucky and happened to notice that 50 was a perfect square times 2, and we used that to simplify it. Okay. Now in general, we might not be that lucky. So here is another instance. Let's try simplifying the square root of 396. Okay. Now, what we're going to do here is we're going to set up a factor tree that will let us methodically find all the prime factors of 396 and see which ones will combine together to give me some nice perfect square factors. That might sound quite mysterious, but I promise it's methodical, and once you've seen it once, you can do it 100 times. So a factor tree is just pairs of factors of that number that I keep breaking down into more and more factor pairs. Okay? So you just need to hunt for a pair of numbers multiplying to give us 396. Okay? Now you might spot your own factor pair, but I happen to spot that this is 4 times 99. Okay? Certainly the case that 4 times 99 is 396, but let's keep going. Okay? Because neither 4 nor 99 is a prime number, I can factor them in interesting ways. So let's see, 4 is pretty incontroversially 2 times 2. 2 and 2 are both prime numbers. Indeed, it's the same number twice. They're prime numbers. We can't go any further down the factor tree there. But 99, okay, I think about it for a second. I realize 3 divides 99 with its partner 33, right? 99 is 3 times 33. That 3 is a prime number. I can't get any further, but 33 I can write as 3 times 11. Again, 3 is a prime. I'm done in that branch of the factor tree, but so is 11, right? 11 is a prime number, so I'm done with that part of the factor tree also. So now what I want you to do is look at the bottom row all the way along your factor tree and pair up numbers that look the same. Okay, so I happen to have 2 and 2 together, and I happen to have 3 and 3 together, and 11 is just hanging out doing its own thing. Okay. Now, how is this factor tree going to help us simplify the square roots? Well, what we've essentially shown there is that 396 is 2 times 2 times 3 times 3 times 11. That's what our factor tree has allowed us to write down. But indeed, right, I can write it as 2 times 2 is 2 squared. 3 times 3 is 3 squared. And then I have that 11. Okay. Now, the really nice thing about the product property is that it works for products of any length. Okay. The key takeaway is that the square root of a product equals the product of the square roots of those factors. So what I can do here is I can pull this square root apart as the square root of 2 squared times the square root of 3 squared times the square root of 11. Okay. Well, the square root of 2 squared, square root of 4, that's just 2. Square root of 3 squared, that's just square root of 9, that's 3. And then, okay, square root 11 is just kind of doing its own thing. So here, this factor tree has allowed us to fully simplify this square root as 6, that nice positive whole number, times the square root of 11. And the square root of 11, that 11 has nothing else helpful that I can pull out the front by finding a perfect square factor. Now, one last quick example I want to show you is again asking you to simplify a square root. But again, it's a little bit of a trick question, just like we started today's video with. Okay, let's try and simplify the square root of 30. Okay, now nothing obvious is jumping out at me, so let's try and use our factor tree. So let's hunt for factor pairs of 30. Well, 30 is certainly 15 times 2. 2 is a prime, so I'm done there. But 15 factors further as 5 times 3, and 5 and 3 are both prime, so my factor tree is complete. So really what the factor tree is telling me is that 30 equals 2 times 3 times 5. But that's actually not that helpful, right? Because if I look at this, okay, I can write the square root of 30 as the square root of 2 times 3 times 5. The product property lets me pull this apart as root 2 times root 3 times root 5. That doesn't look a whole lot simpler than root 30. Okay, some people might say it is. Again, simplicity is in the eye of the beholder. It's the square roots of smaller numbers. But I have 3 kind of nasty looking square roots multiplying rather than just that one single square root of 30. So generally, we're going to think of, in this situation, the square root of 30 as already simple. And we just kind of wouldn't worry about rewriting it like that. Now, if you want one more minute of math, I've got a challenge problem for you. And that is to use this factor tree method to simplify the slightly hairier looking case of 62,400. Simplify that square root. Do leave me a comment below if you have any questions about simplifying square roots using this method, or if you have any requests or ideas for what to cover in our next video. And as always, if you want to do X minutes of math, Y more times, don't forget to subscribe.